Hello, algebra students. Mr. Lawrence here, and we're going to learn something tonight called solving systems by elimination. Now, first of all, taking a look at this system here. To solve this by substitution would be kind of a pain because as I look, my coefficients 3 and 4, neither of them go evenly into 7 or into each other. And here 2 goes into 4 evenly, um, but it doesn't go into 13 evenly. I guess if I wanted to, I could go ahead and, you know, solve for x in this equation. It'd be probably the best choice. So I'd get what, 13 plus 4y. And then, of course, I'd divide by 2, divide by 2, divide by 2. And then x would equal 6.5 plus 2y, right? Now I'm ready to take the other equation, the original or the first equation, 3, and instead of writing x, I'm going to write 6.5 plus 2y. Now it's a good way to do it. It works. The numbers aren't as friendly, but there's nothing wrong with this. So let me see. That's 18 and then 1.5. I think it's going to be 19.5. Yeah, that should be right. And then plus a 6y plus 4y equals 7. So I'm going to have a 10y plus 19 and a half. Oops, not writing a half very well there. Sorry about that. Okay, so 19 and a half. That's going to equal 7. And then I'm going to subtract 19 and a half from both sides. I'll get 10y equals negative 12 and a half. I'll divide by 10, divide by 10. And then y is going to equal negative 1 1/4, 1 and 25 hundredths. Okay, then of course to find x, I can come up here and go x equals 6.5 plus 2 times negative 1 1/4. Okay, and then x would equal 6.5 minus 250. And I think that x is going to equal 4. So it's not such a terrible answer. Wasn't that bad to do, but in this particular type of problem, there's an easier method called elimination. And I'm going to model that for you here as soon as I can figure out what the heck is going on. So let me get rid of all this work. Just remember 4 and then negative 1 1/4, okay? Remember those numbers for me. All right, so let me get rid of all this work here. Oh, that's cool. Usually it's this gigantic eraser that I can't control. That's why I didn't go to it right away. All right, let me put it back on that, and let's see here. Okay, now we don't know how to solve one equation with two different variables. The whole point of having two equations with two different variables is so that we can get rid of one of them. That's what we were doing in substitution. So we could rewrite this as one equation. Well, since there's a positive 4y and a negative 4y, if I add these equations together, I think I'll have only, what the heck is that? I'll only have one equation in one variable, namely x. Because when I add these together, watch what's going to happen. I'm going to get 5x. Those will cancel each other out, and I'll get 20. Now, I'm going to divide by 5, divide by 5, then x equals 4. All right, so x was 4. Isn't that what I said x was before? Now, I have to take this 4 and put it into one of these two equations. I guess I'll put it into the first one. It doesn't really matter. If one looked easier than the other one, I would use that, but that's not the case. So I'm going to get 12 plus 4y. That's going to equal 7. I'm going to subtract 12, subtract 12, and I'm going to get 4y equals negative 5. Divide by 4, and I think you can see that y is going to be, I have a mistake, don't I? Yeah, I should be dividing by positive 4. Sorry about that. Negative 1 and 1/4, or 1 1/4. Notice I got the same answer, and it was a little less work. Now, some of you go, well, why didn't you show me that? Well, it's not always smartest to use elimination. Personally, when I was a kid, learning this in high school, I don't remember learning in Algebra 1. I remember learning in Algebra 2 as a ninth grader. We took it in a different order than you do. I remember liking elimination better than substitution. But now that I'm an adult, now that I have a lot more experience in algebra, I like substitution better. I find I make less mistakes with it. I get a better answer. Now, but we need to know more than one method. So let's take a look at this one. We're going to do it by elimination. The only problem is you notice how none of the coefficients match up. I'm going to rewrite that y there. Looks a little bit sloppy. All right. Well, none of them match up. If I add them together, I'm going to get 7x, 10y, and 4. And I'll have one equation, two variables. That won't do me any good. But what if I decided to get rid of my x's and I multiplied the top equation by 5 on both sides. Oops. There we go. And I multiplied the bottom equation by -2. What would happen then? Well, the top equation would become 10x plus 15y, and that would equal 5, right? The bottom equation would become -10x minus 14y, and that equals -6. Now, notice how my coefficients match with opposite signs. They're additive inverses of each other. So now if I add, my x's will cancel. 15y plus -14y would be y, and 5 minus 6, 5 plus -6 is -1. Oh, so you see I can manipulate the coefficients by distributing. Okay, now I want to do it in such a way that I get coefficients that are additive inverses of each other, 5 and -5, or 17 and -17, something like that. Now, I still have only found y. I got to go back and find x. Now, I have a choice. I can use either of these equations, or I can use one of the original. I'm going to go ahead and use the original. I'm going to use the first one. So I'm going to get -2 plus 3y equals 1. And I'm going to add 2 to both sides, and 3y will get me 3. And then dividing by 3 on both sides, I will get y equals 1. So, oops, I have a mistake. Sorry about that. I goofed, ladies and gentlemen. I need to plug y, the -1 in for y, not for x. Silly me. Sorry about that. Okay, so I'm going to go 2x plus 3 times -1. That's going to equal 5. So 2x minus 3 equals 5. And then 2x is going to equal 8. And then x is going to equal 4. And so in this problem, I have the answer for -1. It's just a coincidence that x is 4 again. Now, did I have to get rid of the x's? No, I could have got rid of the y's. I could have multiplied the top equation by, say, 7 and the bottom equation by -3. That would have done it, right? Okay, let's see this one. Now, this one here might be easiest to get rid of the y's, because I notice 3 is a multiple of 6. I'm sorry, I said that backwards. 6 is a multiple of 3. So I'm going to multiply this top equation by -2. I'm not going to multiply the bottom equation by anything. So the top equations become -4x minus 6y equals -18. The bottom equation, since I didn't do anything to it, stays the same. And notice here, I have a -6y and a +6y. All right, I'm going to add these two equations together and get a -x. Those cancel. I'm going to get a -11. Now I'm going to divide by -1, and x is going to equal 11. I think I'll plug x into the second equation here. Oops, 3 times 11 plus 6y equals 7. 33 plus 6y equals 7 minus 33 minus 33. Okay, 6y is going to equal negative 26, right? Divide by 6, divide by 6. Well, first I'm going to simplify. I get negative 13 thirds. So then y is going to equal negative 4 1/3, I believe. Yes. So the place where these two lines cross would be at 11, negative 4 1/3. All right. So let's see here. This one here. It might be easiest to get rid of the x terms. Now, granted, these have opposite signs, but to get rid of the y's, I'd have to multiply the top equation by 4 and the bottom equation by 3. To get rid of the x's, I only have to multiply the bottom equation by negative 2. And so I think I'm going to do that. Times negative 2 times negative 2. So my top equation remains the same. And my bottom equation becomes negative 4x plus 8y equals negative 2. All right, those are going to cancel when I add the equations together. That'll become 11y, and that's going to become 11. Dividing by 11, I get y equals 1. Now, it wouldn't matter if I got rid of the y's or if I got rid of the x's. I'll still get the same answer. I'll just get them in different order. So let's do 4x plus 3 times 1 equals 13. 4x plus 3 equals 13. 4x equals 10. Divide by 4. Divide by 4. X is going to equal 2.5, I believe. Yeah, so the place where they cross is at 2.5, 1. All right, that's it for the video. You might want to go back and look things over. Remember, to solve by elimination, we need to make one of the coefficients in each equation. I should say matching variables have the same coefficients except one be positive, one be negative. So we want the variables to be additive inverses of each other. That's how we really need to say that. Additive inverses of each other. Okay, when they are, we can add them together, and then the variables that are additive inverses of each other will cancel out. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.